Welcome everyone. This is lecture 2 of the project software project IT3030, IT3090, both individual and team projects. This is our second week and we're going to start working on expanding the ability to do better communication. So the core today is understanding a reliable resources for software project development, moving beyond literature review. So in software development, yes, we need to use literature, but we move beyond and we're going to start using much more technical documents, managing project scope and expectation, and ensuring academic integrity when using external sources. So let's cover the first part, which is about understanding what is sources. And it is okay to use the knowledge as long as you acquire the information from another source legally and is public, or they might be on a library and so on. What it becomes very important is that you report that you use that information and so on. And for the specific case of UHE, for us it's important that you have a responsible use of AI and automation tools. So it's impossible for me to think that UHG students, which want them to be top leaders in project and software development, they don't use key scripting technologies like ChatGPT or a stack that puts everything together that Bogdan knew, or have Copilot. The important thing is to acknowledge that you have using it, and in this it becomes important that you tell me what was the prompting, what was the lesson that you learned, and so on. Now, please read our academic misconduct policy at UHE. It tells you what is correct and what is not, and the consequences are severe. So pay attention to this. What you must be very careful is to use something without telling the reader, telling me as a lecturer or the readers. So if you found something on the web, acknowledge it came from someone else. Don't do it directly. If you decide to use technology for scripting your software, make sure they know that that is what is had happened. Let's talk about what are preferred sources for academic paper. For information that you're doing in this project, part of it will be academic. In other words, you're going to learn, for example, in your project, that you need to understand what are the key processes, key projects in the industry that you're looking at, and what are the key sources. So a very good important sources is peer-reviewed journals. Peer review means that someone provides a paper. A paper is basically an academic writing in where you process some data, you went to a lab, an experiment, you develop some code or so on, and you tested it, and you report on the findings for others to know. Normally, academic papers are developed by us academics. So we work at universities, we work at an academic institution or research institution like CSRO, and we present those as contribution to knowledge. You can imagine UHT and as academic registered training organization has two purposes. One, producing knowledge. Two, transmitting that knowledge. So the way we transmit knowledge is through academic papers. But when they are peer reviewed, means another person with similar qualifications to me will review my work and make sure I follow the standards, follow top quality, was able to produce very important references. I was not doing plagiarism or doing illegal or changing data and so on. So that becomes very important. So the number one source is peer review papers. Then you need to talk about university library databases. And those will be important because they are engines of databases that allows you to find information. And a good one that also is very useful is Google Scholar and ResearchGate. That's where we report. Google Scholars try to collect all the information from all the researchers, while ResearchGate is very specific for academics that want to report their information. And then you need to think how to apply these research papers. So a key part start with initial papers that perhaps help you to do something, and then move into review papers that give you a sense what is important in that in what you are studying, and at the end identify a gaps, and maybe in that gaps you can reuse ideas or provide a different approach. I'll give you a very high level example. you want to work in the banking industry. Someone wants to work in finance. So you will go and look papers about security in the finance sector, and you're going to develop some sort of software for security. You are interested in that area. Through the papers, you know that a lot of the banking sector has been working very hard in preventing um, cybersecurity, for example, phishing. And through that, you learn that there's a lot of good ideas to prevent that, to authentications, messages, blocking of the account, many things. But you think you can help the users further with an application that help them tracks on the SMS. I'll just give an example. So you follow this process of going and understand what I've done before in this particular area of cybersecurity for banking, and you apply it by identifying the gap. What have been done, what will be good to do, and what part of that gap is being filled by your project. That's a very high level example of what we expect you to do in this project. Now, what is a good way? I mean, you read a paper and it's very long, it's 20 pages, 7,000 to 10,000 words. So what is a good, effective way to process it? I recommend 5 steps, typical steps that you learn when you do a doctor or a PhD, which you need to be an academic. And basically, the first thing is read the title and abstract, check if it makes sense. Then go step 2, skim the introduction and conclusion. So you go from the top to the bottom and say, is this relevant to me? Is this what I'm looking for? And if it is, go identify the problem statement and methodology. What is the part of the we're solving? We're solving what part of cybersecurity for financial sectors? And finally, note what has been achieved and what remains unexplored. The researcher must say, I developed this code, but part of it worked, part of it didn't work, or there is something that it could be useful if someone else does it in the future. Ideas for you. And finally, document relevant insights and reference them properly. So you know you found this, could be useful for my project, and I can quote it in my documentation. Now, for IT, we need to expand beyond literature using technical documents. It's typical, like for example, if some of you are gonna use an API, and we will talk about it at class, an API for artificial intelligence or generative AI. You're gonna use an API with their technical documentation. So it's gonna be a framework that is tells you how to use it and so on. So you need to have that in place. And the same happens with databases. I mean, there are multiple databases. Kaggle is one of those. The one that I use the most is Supabase. And I will go to the documentation. No, you now, for example, can add functions on the server side of the database, or you can put it on your deployment server, or you can do it at the user server. So those will require to understand what is being used and who can not use code repositories. Like GitHub will have many open repositories that might be doing some code that you already have done, so it makes sense that you use it. It becomes very important to understand. Papers are good, but in IT, we go to technical documentations. Now, what is the scope of a software? You can imagine a software can do everything, but even Microsoft, that has Office, has divided the scope of the different parts of Office. One part is to write documents called Word, another one is to process spreadsheets or do calculation called Excel, another one is to do presentation of graphic ideas, that's called PowerPoint, and so on. Microsoft project, they divide the tasks. So you need to think that your application will cover one of the tasks that is needed in, let's say, financial services cybersecurity. It will not make sense that you think the scope is completely open and let's try to solve everything. No. You will find in the literature and talking to the industry partners that there are very big problems, and your application, with the resources you got, you will be able to respond maybe a fraction of that particular one. Let's remember something that we talked about in lecture 1. We have the famous triangle of all projects. I'm sorry for my writing, which is not perfect. One is time, the other one is resources, expense, and the other one is quality. So you try to be between those three. You try to be in the middle of this triangle that tells you what is quality acceptable, what is time acceptable, and what is resources acceptable. And this project is very obvious. Time is 12 weeks, now 11 because we're in week two, and the quality is the one that we established for the rubric. Then you need to manage the resources that you're going to spend. Your time is the most important resource. You might use a little bit of resources also to get process some of the data with script writing and whatever, but you know that is kind of the key emphasis of what you're doing. Now, work breakdown structure, WBS, work breakdown structure, and task allocations. Breaking a project into small tasks make it manageable. No, even you have a big, you have decided, okay, my application is gonna do this. Now, to be able to do that, I'm gonna go modules. I'm gonna do work breakdown structures. WBS is not web-based services in this case. It's work breakdown structures. Means you have different structures that allow you to understand how your application is going to be developed. What is the main deliverable? The web application. But I'm going to subtask. I'm going to have an UI design, backend development, maybe an API integration with a scrapper or artificial intelligence, whatever else I'm doing. Database setup, as I said, you can do functions in the database, so the database does something with the data before processes, and of course testing and debugging. So you can see that I have a massive web application delivered, and the web structure that I'm going to develop is going to be broken into work breakdown structures. Now, the scope is difficult, and an effective scope management approach fosters open communications and sound decision making to ensure all parties get the business value expected from the project. Someone is paying you for that project, someone expects a quality, and there is a limited time you can spend in the project. In this case, because it's an academic project, you have a constraint. The scope needs to be managed carefully so you get a good score in your assignment, you get a product that you can show others when you graduate from this bachelor's, and you are expected to meet the requirements of a program like in the bachelor's of IT. So those things is what create a good scope. The scope that the lecturer is satisfied, you have done the work, you feel satisfied because you didn't overwork and underwork, and ultimately you got something at the end that you can show others. Now, the scope planning flow. This is a high level diagram. We will talk more about it, but basically there are key concepts we are discussing and they are connected. You talk about plan scope management, collection requirements, define scope, create work breakdown schedule, and perform integrated change control. That is at the top, and each of those tasks will have a corresponding outcome. Scope management plan, requirement traceability metrics, scope statement, scope baseline with WBS. You know, what are how you're gonna chop the different tasks and approve changes and updates. Now, stakeholder registration becomes always very important. Everyone is going to have different stakeholders. Sometimes the stakeholder is something doing something with your application, is the user, it might be the sponsor, the institution. There's many stakeholders you want to do. We will talk more about that in the next week. Now, what are good tools? We will practice these ones in our project. I mean, first thing we need to design the project by going into the literature and finding what hasn't been done and what could be done. But typical project and collaboration tools are Trello, which is kind of buckets that you work. Everyone should practice with Trello. There's a free version you can use. There's other ones like Jira and Notion. Now, version control in software development is very important. GitHub is my favorite one. You might have GitLab. Whatever you use is a system in where I have version control and I allow it to be public or private. For those of you that doing the group project, you have to have a version control system. No, it cannot be just a different file every time. No, I want to see something in GitHub or GitLab or whatever you want to use. And technical documentation, we don't use a lot of EndNotes. There is a course, by the way, in UHE and information to do it. It's up to you, but as a minimum, use the reference systems that is inside Word to make it very responsible when you acknowledge that others have to know where you got information for. Now, Leveraging industry resources for your project. You cannot be in a vacuum. You need to work in industry, and a key part of that is the industry context, networking. I'm gonna offer you some context, but you should use LinkedIn and meet and with people online or in person, particularly here in Australia, in Melbourne, to be able to develop. We're gonna have guest lectures where people from industry will gonna come to chat with us. We're gonna have that to give you ideas, but it become important for you to explore real world case software. I want to see that happening. Okay, well, we're gonna do some hands-on activities during the class. Be prepared to get dirty. We're gonna talk about key research and technical activities. We'll do it during the class, and also the front project scope. That's gonna happen on our lecture in person. And as a summary for this week 2, very important, go beyond literature review. Remember, we are developing software, you use databases, API documentations, and other parts that tell us. Manage project scope effectively using WBS. You break down the work and task prioritization. What is more important than the others? And finally, utilize around tool for research, project tracking, and documentation. They are software pretty much free that allow you to do better. Be ready because in week 3, we're getting closer to the final project, refine project scope based on research and feedback. We're going to draft and finalize the project proposal and industry engagement and network. Thank you for listening to recording of week 2, and we'll see you in class, and keep reading and use the material that we'll be giving you in the lecture.